Hi everyone, this is going to be the final review video. Sorry for the final exam for our climate class. It's just going to be like last time where you can use the video on your own time, stop, pause, rewind as needed. So what are the three main phases of a grain plant's life cycle? The three main phases are vegetative, reproductive, and grain filling. Vegetative is where we start growing leaves, reproductive is where we have our flowering stage, and grain filling is where we produce a fruit. Is C3 or C4 respiration more important, and why? C4 is more efficient. C3 is very basic, so it has no mechanism to prevent energy escape. C4 is a little bit more complex, as you can see here, and it's developed a couple of extra steps to keep energy from getting lost unnecessarily. What is the most commonly used type of clean or emission-free energy in the world right now? Nuclear energy. So this question's a little bit tricky. I'm not asking what the best type of energy is. I'm not asking what the most common type should be. The most common type of clean energy currently used in the world is nuclear. It accounts for about 16% of all energy used. Solar currently accounts for only about 4% of energy used. What happens to surface temperature, to the ground surface temperature, as we add more hypothetical layers to our atmosphere? The more atmospheric layers we have, the warmer the ground surface temperature is going to be. So ground surface temperature increases as we add more hypothetical atmospheric layers. This is because we have more opportunities to trap heat in a multi-layered atmosphere, but we still only have one chance to let heat escape into space, that being the outermost layer of the atmosphere. If you want more information on this topic, go back and review chapter 11, as well as the Mars PowerPoint. Considering the risks of methylmercury, which types of fish are safest for humans to eat? Fish that are low on the food chain are safest for humans to eat because as we move farther and further up the food chain, fish that eat other fish have accumulated mercury from all the other fish that they've eaten. So fish that are lower on the food chain have had less of a chance to build up that mercury. Why are Pacific cod not adapting well to climate change? Cod are doing badly in the Alaska region because they are single batch breeders, which means that they only lay one egg clutch per year, and all the females do it at the same time, which means the eggs are adapted for a very, very specific temperature range in the early spring. Because we have climate change, that particular temperature that's needed for the eggs to incubate no longer exists. So Pacific cod have really dwindled in their numbers. Their eggs are not able to mature into baby fish. This is an example of not wanting to put all your eggs in one basket. What happens during the grain filling phase of the grain plant's life cycle? So in grain filling, we have our plant ovary fused to the seed shell, and this forms a simple fruit, what we would think of as a grain, and the scientific word for this is caryopsis. Examples of this would be wheat or corn. These are simple fruits with a seed shell, the ovary is fused to it. In some cases, you can actually see where the ovary is on the outside, and this is what we would call a grain or a caryopsis. What happens to quality and quantity of wheat grains as we increase exposure to atmospheric CO2? So as we increase exposure to CO2, we end up with more wheat overall, but we end up with wheat that's very low in protein and other nutrients. What type of clean energy is considered by most to be the best? Solar energy is considered by most climate scientists to be the best form of clean energy. We can use a very, very tiny amount of the solar radiation that the Earth receives each day to power all of the electrical energy needs of all of humanity. We don't even really begin to scratch the surface of the amount of energy that we receive, that we would be using. Solar panels are incredibly efficient. They produce insane amounts of energy compared to other types of clean energy. There's no risk associated with them the way that nuclear energy has risks associated with it, such as Chernobyl or Fukushima as examples. And solar panels are relatively inexpensive in the long run. In most cases, it costs less to have solar if you own a house than it does to keep paying an oil company. Why isn't wind energy as good as solar? So wind turbines are not anywhere near as productive as solar panels. That's the main reason. You don't need to know the specific number. but they're just very, very weak in comparison to solar panels. That's not to say that they are actually weak. There are plenty of reasons to still have one. Having a couple of wind turbines can power a large building, but they don't produce as much energy as solar panels. They're also reliant on wind in order to work. So solar panels, even if it's overcast outside, solar panels will continue to produce energy for you based on whatever sunlight they do get. Wind turbines, if it stops being windy, the wind turbines really don't work below a certain wind speed. What are some ways that insects are affected by climate change? So insects are impacted by climate change and then in turn impact other parts of their ecosystem in a lot of different ways. So for one thing, we have more insects overall. We have increased number of generations of insects because we have a longer warm period. And this means the overall number of insects per year is much higher than it used to be. Part of this could also be because the lifespans of the insects may be speeding up as a result of hotter weather, but mostly it's because of the warm climate allowing a longer period when insect generations can occur. The second reason is expansion of geographic range. This is where the areas to the north and south, the higher latitudes, start to get warmer and warmer, and as a result, insects start to move into areas that used to be too cold for them, now are warm enough for them, and we end up with invasive species in those areas. Something that can happen when we have insects going places that they don't belong is our third example, an outbreak of plant diseases transmitted by insects. So we already know that in general, pathogens, diseases are more easily transmittable in warmer weather because of the petri dish effect, because we're able to grow bacteria and germs and viruses and all sorts of things much better in warmer weather. But when we increase the range of different insects who themselves may have a microenvironment inside of them that has all sorts of things that the new environment may not be adapted for, we are subjecting the new environment where the insect is invasive to any number of microorganisms and diseases that may live on that insect. And those diseases, those new environments where the diseases are going, rather, those new environments are not immune to those diseases. So then again, this kind of goes hand in hand with the increased generation thing. Our fourth example is increased rate of overwintering survival. So this is where the insects at the end of the fall season go into hibernation, and they remain dormant until the spring, and then they mate, and then they create the first generation of new baby insects in the spring. So over the winter, a certain number of insects are expected to just never wake up after hibernation. They don't make it through the rough, cold winter, but winters aren't so rough and cold anymore, and so we have more insects that are easily surviving the winter. We have desynchronization of insects and their natural enemies. So the example here is aphids and ladybugs. Aphids can do a real number on plants. So if a plant gets an aphid infestation, that plant's going to get eaten alive. And ladybugs specialize in eating aphids. So if climate change causes a situation where the active period of ladybugs and the active period of aphids move apart from each other during the warm season, then there will be a period of time when aphids are left unchecked without ladybugs on the plant, and they're going to absolutely destroy that plant. And then at the same time, ladybugs will be left without as much to eat. And then finally, we have loss of synchrony with the host plant. So insects and plants in many cases can be symbiotic, meaning that they've evolved to live together and help each other with their various biological processes. In some cases, the same thing can happen. The active periods can get changed because of warming. So the insect's active period and the plant's active period may become a little different. And as a result, the insect and the plant symbiosis gets disrupted. What is the difference between mitigation and adaptation? So mitigation is our direct solution. We're nipping the problem in the bud. We are preventing secondary problems to occur, to branch off of the main problem, which of course is greenhouse gas emissions. So mitigation deals directly with the problem, which is greenhouse gas emissions. Adaptation, adaptation deals with an indirect solving of the problem. So we're not actually solving the problem. We're dealing with a way to change human life to live around the problem instead of actually stopping the problem. Adaptation is usually used in places where mitigation, for some reason, is just not occurring. Mitigation, of course, is the more important type of climate response. So if we think of climate change as a disease, mitigation would be treating the problem itself, and adaptation would be treating the symptoms of the disease. What are some reasons poor people fare the worst in climate-related disasters? Oh, sorry. So I forgot we had this one as a discussion in class more than it was a specific question and answer. There are many different answers to this one. The main things are that in general, poor people may have less of an opportunity to shield themselves from direct exposure to extreme climate conditions. So in areas where we have these extensive heat waves, poor people, if they're homeless, they will not be able to get out of the heat wave. If they're not homeless, but they're just very, very poor, they may not have access to air conditioning, and they may not have access to a generator. So in a lot of these cases where we have these extensive heat waves, 100-degree days for 14 days at a time, in some cases, the heat is so constant and intense that the power grid gets knocked out, and so people have to rely on generators, private types of energy for their home, if they want to be able to run their air conditioner. And you can only have a generator if you have money for one. They cost a lot of money. So those are the main things. Poor people, for various reasons, whether they own a home or they don't, are unable to escape the extreme heat. They also may be unable to escape flooding or drought because they don't have anywhere to go. They may have no way to get there. We talked about that. They may be tied to an area for financial reasons, and it may not be possible for them to go. Poor people also sometimes are unable to access educational resources. Sometimes they're not told of the risks. And there may also be food shortages, as we talked about in an emergency situation. Food resources may become scarce, in which case they get very expensive. So not only do you have people clamoring for resources, but not everyone can even afford those resources. And then of course we have like all the other things that happen. So if there's like a weather disaster, like a flood or a drought or something, they're going to be exposed to those conditions as well. And then if there's like a major emergency, someone gets injured or someone gets sick from a disease or from a major disaster, the hospitals can overflow with people and not everyone will get care in a timely manner. What is the overarching theme of climate justice? The overarching theme of climate justice is this idea that those who are least responsible for climate change are facing the greatest consequences and risks from climate change. And of course, the people who are most responsible for it, and the countries that are most responsible for it, are often at the least risk for any sort of danger in the immediate future from climate change. In India, irrigation channels are sometimes built from glacial lakes in order to prevent explosive outburst floods. This type of climate response would be considered this would be adaptation. So we are not actually solving the problem of climate change. We are just learning to live around it. We are changing the structure of the landscape in order to accommodate this enormous amount of water so that we don't have an explosion. Can catch per unit effort, or CPUE, change dramatically from one year to the next? And if you're not sure what CPUE is, this is in the first of the two fisheries PowerPoints. Yes, so because most sustainability of fish that we commonly eat in the past many years, sustainability has been determined by whether or not a fish population has been over-harvested by human beings. So in most cases, if a fish population gets over-harvested, a good example of this would be red snapper. A few years ago, in the 1980s, and then again a few years ago in like 2015, these fish got really overfished. Apparently they're very delicious. I've never had them. I've heard amazing things about it, but apparently it's like one of the most delicious things in the world, and as a result, they got over-harvested. But you just leave them alone for a year or two, and then their numbers bounce back. So yeah, so basically, if we leave most fish alone in order to let their numbers come back, provided that the problem was caused by overfishing, which it very often usually is, then yes, CPUE can be very dramatically positive, even after it's been really negative, really in the red for a very long time. Are Alaskan king crabs an example of a species that will likely have a dramatic uptick in CPUE from not being fished? So Alaskan king crabs are not a good example of a CPUE of a catch per unit effort that is likely to bounce back dramatically in a year or two after being left alone, because their declining numbers are not being driven by overharvesting. So in the case of red snapper, we leave them alone after we fish too many of them out, and in a year or two, we're back to normal, healthy red snapper populations. That's not the case for king crabs. It's also not the case for Pacific cod because their problem is global warming. Their habitat is so warm that the eggs are not hatching. So if we're going to just keep warming up the planet anyway, then no, we're not going to be able to solve this just by hoping that they repopulate. Honestly, all that we're doing by not fishing them is giving them a little bit of a buffer to prevent them from going extinct until they hopefully evolve a genetic mutation that will prevent them from having these extreme stressful reactions to climate change. What is the name of the statistics value that tells us whether the difference between two medians is significant? So this would be the p-value. P-values are very, very important in statistics. They come up in a few different places. And if you were thinking about going further with science, you are going to see p-values a lot of times in your life. Which type of photorespiration, C3 or C4, is more common, and what does that mean for climate change? C3 respiration is more common, and they account for about 70% of plants, including most of the plants that we eat. C4 plants tend to be grasses and cactuses. So grasses and cactuses do really fine in hot, dry climates. C3 plants, not really the case. They can't hold on to their energy, and so they have to be out of that kind of a place. C3 plants, as a result of not doing so well in warm climates, may be in trouble as global warming continues to get worse towards like decades from now. C3 plants could be in a lot of trouble. And this means a lot of the plants that we rely on for our food and for our food's food and for oxygen and for protection against erosion and for protection against carbon leaching from the ground into the atmosphere. Basically, we need C3 plants, and basically the plants that are going to have a problem in the future from climate change and then potentially become an additional problem on the environment are C3 plants. Why are purple sea urchins so unusual in their response to climate change? adaptations have really, really rapid evolution. So they dramatically evolve some really, really different, dramatic, major adaptations in just one generation. So two things could have happened in just one generation. One of two possible adaptations appeared in the children of the original sea urchins. Either they had a smaller exoskeleton as a result of acidification, or they had a genetic mutation that protected them from ocean acidification in the first place. The two adaptations are not necessarily the most important thing here to know, although they do have implications for other sea life if that is something that interests you. The main thing to understand here is that that evolution was so rapid. And that is very uncommon for any sort of complex organism, which a purple sea urchin is. Um, Very, very uncommon. And given how rapid the climate change that we humans have created is going, just 200 years instead of 10,000 years, that is the type of rapid evolution that guarantees that your species will be okay. And it's very rare. What is going on with baby sea turtles? Sea turtles are all being born female because sea turtles are part of a group of really evolved reptiles that, along with alligators and dinosaurs, have something called temperature-dependent sex determination. That means that during their incubation as eggs, the temperature of the nest is what determines the sex of the babies in those eggs. So if we have temperatures of 88 or above at the ground surface temperature where the sand is, we're going to have just females. If we have 82 degrees or cooler, we're just going to have males. Anything in between there is going to have a mix of males and females. So as surface temperatures of the beach around the world get hotter, we have more and more surface temperatures at 88 or above during the sea turtle breeding and nesting season. And this means that we have fewer and fewer male turtles. The past several years, we've had almost entirely all female sea turtles. And this means that in the future, sea turtles may be facing a crisis in terms of their ability to reproduce. We talked in class about how rare it is for a sea turtle, any given baby sea turtle on the beach, to make it all the way to adulthood. So we really need every single sea turtle, male and female, to have a good chance. But right now, the male turtles really don't have a chance because there's nowhere for them to be incubated. What are some indicators for life on a planet other than Earth? So we want to see an organically produced greenhouse gas such as methane, which we do see on Mars around the equator. We also want to see evidence of water. We may not see actual water, but we want to see liquid water or evidence of it. Why are cephalopods going blind? The lack of oxygen in the water, relative lack of oxygen in the water caused by global warming, making it harder for atmosphere and surface water to mix, means that there's less oxygen supply to flow to the cephalopods' complex brains and their complex eyes. So cephalopods and crustaceans are very similar to us humans in a respect. So we humans have a very complex brain, we have very complex eyes, and this means we need a lot of oxygen flow to our brain to power our brain and our eyes. Cephalopods and crustaceans have the same type of thing. Really complex brain, really complex eyes. Some of them can see more colors than we can, and so they need a ton of oxygen to their brain. But the warming of the surface of the ocean has created a film of like kind of hot water that makes an impenetrable barrier between the surface of the ocean and the atmosphere. This causes us to have less oxygen in solution in the water. As a result, there is not enough oxygen available to cephalopods and crustaceans, and this could, as things get worse, start to cost these types of animals their vision. Describe the main phases of a grain plant's life cycle. Vegetative, reproductive, and grain filling. So vegetative, again, is what we call the part of the plant cycle where we have leaf initiation. This is everything after germination and everything before flowering. Reproductive is when we're just dealing with the beginning to the end of the flowering cycle. And then grain filling is when the flower has disappeared, and in its place we have a simple fruit. Which type of photorespiration is more efficient and why? C4 respiration is more efficient. C3 respiration is so basic that it has no mechanism to prevent energy waste. So when you see some question to this effect on the test, be mindful of whether I'm asking for the most efficient or the least efficient photorespiration style. Again, if you are curious about this, the C3 pathway is very direct, very simple, and there's no mechanism in place to prevent us losing energy. The C4 pathway has extra steps. Sorry, I need to click ahead. And as a result of these extra steps, we keep more energy in, we have less energy escape. Which type of clean energy is currently the most commonly used in the world? Nuclear energy is currently the most common source of clean energy in the world. It accounts for about 16% of all energy used. Solar, however, is the holy grail of clean energy. That would be a separate question. And solar, unfortunately, accounts for only 4% of energy being used right now. What happens to temperature at the ground surface of a planet when we add more layers to the atmosphere? the more atmospheric layers we have, the warmer the ground surface is going to be. Again, this is because we have more opportunities to trap heat in a multi-layered atmosphere, but we still only have one chance to let it escape into space. And then again, just to point out, Earth is not unique in terms of this pattern. We know that Mars also had a similar pattern at some point. The more layers it has in its atmosphere, the warmer the ground surface would have been. Which fish are the least safe for humans to eat? And again, be very careful when you're taking the test. Am I asking for the most safe or the least safe? So fish that are higher on the food chain are the least safe because we know from the mercury cycle and the food web in the ocean, basically, there are no vegetarians in the ocean. And we have just a cycle of little fish getting eaten by progressively larger fish. But all of the fish have some kind of mercury in them. And so the more fish that you've eaten, the higher your own mercury content is going to be. So the predatory fish at the very top of the food chain are going to be the ones that have the highest mercury. Even if you're not an infant or a pregnant person, there can be risks if you're eating a lot of mercury content in fish. So again, if you are curious about whether or not the fish that you're eating is safe, please check out the fisheries PowerPoint with the chart that had some ideas for safe and unsafe seafood choices. How come Pacific cod are doing so badly? Pacific cod are single batch breeders, which means that they only lay one egg clutch per year, and all the female fish do it at the same time. And this means that the eggs are only adapted for a very specific temperature, as opposed to multiple batch breeders who could lay their eggs at any point in the season, and therefore genetically the eggs have to be adapted to a range of different temperatures. So climate change doesn't really affect the multiple batch breeders as badly. Describe the grain filling phase. The grain filling phase is normally the phase that we talk about when we're talking about the effects of CO2 in the atmosphere and climate change on grain plants. Occasionally we'll be talking about other phases, but normally what we're talking about is the grain filling phase. This is the phase where the plant ovaries seal to the shell of the seed, and this forms a simple fruit, what we would think of as a grain, and the sciencey word for that is caryopsis. What happens to wheat as we raise the amount of carbon dioxide in the atmosphere? As we increase the exposure of atmospheric CO2 on the wheat, we end up with more wheat overall, but we end up with wheat that is lower in nutrition, and it in particular contains less protein. Which type of energy is considered the holy grail of renewable energy? Solar energy is the holy grail of renewable energy. Basically, the sun sends us more energy every day than we would ever possibly need. It's an incredibly renewable resource for us. Solar panels are wildly efficient and they're inexpensive, and they produce energy even on overcast days, and they're just pretty perfect all around. What makes wind energy not the holy grail of clean energy? Wind turbines are not anywhere near as effective as solar panels. Solar panels create a lot more energy. Solar panels also work in a range of weather conditions, whereas wind turbines require a lot of wind in order to work. What are some insect-related problems caused by climate change? So there are many different effects of climate change and insects. The main things are that we have more insects because we have increased number of generations due to the longer warm season, and we have also due to the milder cold season, we have increased chances of overwintering survival. So between those two things, increased number of generations, increased overwintering survival, we have higher numbers of insects every year. We have the expansion of the geographic range, which means that as certain environments that used to be too cold for insects get warmer, we end up with more and more invasive species. What goes hand in hand with this is plant diseases getting transmitted by insects, especially if they are invasive to an area where the plants may not be immune to their disease. Then we have desynchronization events. We have the desynchronization of insects and their natural enemies. We could also call this a prey mismatch. So aphids prey on the plant, the ladybugs prey on the aphids, but if climate change starts to disrupt the natural cycle of ladybugs and or aphids, then the active periods of one or both of those groups may shift in the season, and then there may be a period of time where ladybugs go hungry. There could also be a period of time where aphids are left unchecked to destroy all the plants. And then kind of hand in hand with that is the idea of the loss of synchrony with a symbiotic host plant. So if something happens from climate change to disrupt the active period of either the plant in some phase of the plant's life or of the insect life, then the symbiotic relationship could be disrupted or even destroyed. How do the 4 climate response types differ? So again, I'm sorry, that's supposed to say adaptation, not attribution. Mitigation treats the problem directly, the problem, of course, being carbon emission. Mitigation does away with carbon emissions altogether. Adaptation, instead of dealing with the problem itself, it deals with curbing the disasters of the problem. So if we have a flood risk from climate change, then we might build a seawall in order to prevent the flood. CO2 removal only deals with CO2 that's already in the atmosphere, and it doesn't really help with other greenhouse gases. And then solar radiation management is incredibly controversial. I think most of us agreed it's not a great idea, and it has a lot of problems. Why do poor people fare the worst in climate-related disasters? So this has a lot of different answers as well. Basically, poor people may lose their access to food. They may lose their crops for the year, their farmland. They could lose their home and not be able to rebuild it. They may have um, more direct exposure to harsh elements to do with climate change, such as heat waves or extreme sunlight. They may not be able to get out away from that exposure. They also may not be able to afford a generator or an air conditioner. They may be more at risk to be exposed to flooding, and they may have food become very, very inaccessible. They could also have medical care become very inaccessible. And there are many other reasons as well. Disease could get worse where they live. Lots of different answers here. It's kind of a ripple effect with many of these problems. One thing happens and then another and another. So yeah, just know a few of these, just know a reasonable amount of these answers and you'll be fine. What is the overarching theme of climate justice, I'm sorry. The overarching theme of climate change is that those who are least responsible for it are the ones facing the greatest consequences and the greatest risks from it. California's policy to have all electric cars by the year 2035 would be an example of which type of climate response? This would be an example of mitigation. It deals with the issue of carbon emissions directly. Is the sustainability of fisheries flexible or inflexible? Sustainability of fisheries in most cases, with the exception of climate caused decline, is flexible. So if it's just an issue of overfishing, it's flexible. The only time when it's not flexible mainly is because of climate change. Can we protect Alaskan king crab sustainability simply by not fishing them? So we can't protect them just by not fishing them. All we're doing by not fishing them is giving them a little tiny bit of a buffer to prevent them from going completely extinct. Basically, their numbers are declining because of global warming, not from overfishing. So as we warm up the ocean in the North Pacific, we end up with eggs that end up not being able to grow into baby crabs. Same thing with Pacific cod. The embryos get arrested and they stop growing in the eggs, and the eggs just don't live because the water is too warm. So if we're just going to keep making the water warm and having warm water is the problem, then we're not really looking at a catch per unit effort for these two particular stocks that could come back in just a year or two. These fisheries will have to be left alone for a very long time, and we have to hope that they mutate genetically in order to adapt to the changing climate. What is the name of the statistics value that tells us whether or not the difference between two medians is significant? This is the p-value. Again, you will be very likely to encounter this again if you continue further with science. Which type of photorespiration, C3 or C4, is more common, and what does that mean for climate change? So C3 is more common. It accounts for about 70% of plants. And C3 plants are in trouble in terms of climate change because as we get more towards a very hot world, C3 plants will be out of their element and they may not be able to survive it. So if you see some version of this question on the test, again, be careful with most and least here, and also be careful whether I'm talking about whether I'm asking if it's efficient or if it's common. So I may ask, which is the most efficient, which is the least efficient? I may ask which is the most common. I may ask which is the least common. Just be careful of those words. Don't read half the question and assume you remember the whole question, because there's 4 possible questions this could be. Why are purple sea urchins so unusual in their response to climate change? Purple sea urchins have extremely rapid evolution to protect them from climate change in ways that other animals just don't. That is what's so special about them. So they have 2 possible adaptations, but both of those adaptations were evolved in just 1 generation, just going from parent to child. We had 2 very significant adaptations, 2 very significant differences between the parents and the children. What is going on with baby sea turtles? Basically, all baby sea turtles are being born female. Sea turtles have temperature temperature dependent sex determination, which means that during their incubation, if we have 88 degrees or warmer, we are going to get all females. If we have 82 degrees or cooler, we are going to get all males. And as surface temperatures of beaches are getting warmer and warmer, we are producing almost no male turtles, basically no male turtles. So sea turtles in the future will very likely, if this doesn't change, will very likely only be female. What are some indicators for life on a planet other than Earth? Organically produced greenhouse gases, such as methane. We see methane around the equator of Mars, which is an indicator that it did have life at one point, if it doesn't have some sort of microbe right now. The other big one is any trace of liquid water. Why are cephalopods going blind? Cephalopods are going blind because we're preventing mixing between the surface of the ocean and the atmosphere by warming the surface of the ocean. And that means that there is less oxygen available in solution in the water. And as a result, there is less oxygen supplied to the octopuses and squids' brains. And this means that their extremely complex brain, which requires a lot of oxygen to function, is not able to power up their very high-powered eyes. Okay, so that was the last question on the review. I hope that you found this helpful. If you have any questions, please send me an email at any point between now and when class starts. Feel free to use this PowerPoint video as much as you want. Use it with a friend, use it by yourself, use the actual PowerPoint as flashcards with a friend. Do whatever works. I think you're all going to do really well in this test. I really am not worried about anybody. I think you're all going to do fine, so I hope you're not nervous. But if you are nervous about anything, please just reach out and I will help you in any way that I can. It's been really wonderful teaching all of you. I appreciate all of you, and I think you're all doing amazing.